Alright, so today we're going to be doing 5.1c, which is estimating with finite sums. So we're taking all the skills that we've learned about over the last 2 lessons, and now we're going to kind of analyze them with a vocabulary aspect. You'll see. Reminder, it's just reminders from stuff we've already talked about. Rectangular approximation method and Riemann sums, both are definitions you need to know for the quiz and test. Okay, so just make sure you're reviewing that. I'll remind you again and again, but yeah, those are important. So we have something called over approximation and under approximation, and that can happen with left and right rectangular approximation method. But we're going to be able to talk now about specifics of when one is an over, one is an under, and all that. And that all depends on whether the function is increasing or decreasing on that interval. So, anytime you're dealing with an increasing curve, LRAM will always be an under approximation, and RM will always be an over approximation. And I'm going to show you the reasoning behind why that's the case with some sketches. So I'm just going to choose to go 1, 2, 3 for all of these, or sorry, 0, 1, 2, 3, just to help you so I can like reference a number and you know where I'm looking at, versus if I'm just like putting dashes in. So if you want to go ahead and put those all in right now, go for it. I just find it easier to explain when I have numbers to say. Okay, so we're talking about increasing curves. So there's several different types of increasing curves you can look at. I'm going to do one that has this exponential look to it, and I'm going to do one that has this logarithmic type look to it, downward. Oh wait, I need them to be increasing. Just kidding. This one. How did I do it last time? Why can't my brain do this right now? So this one's... I just can't picture how I had it looking last notes.
Mr. Russell, is the one that goes like that?
Yeah. Duh. There we go. I literally had like 2 hours of sleep last night, so bear with me. Okay, so those are 2 examples of increasing curves, okay? Increasing curves. Doesn't really matter what ones you pick, but I'm just trying to show you 2 different examples. So if we're dealing with LRAM, okay, LRAM, if we look at each interval for LRAM, what's special about LRAM? We use the left end of the interval to determine the height of the rectangle. Very good. So you see how at 0 we're here, okay? LRAM gives us that height of that rectangle, okay? We use the height at 1. And then for 2 to 3 we use the height at 2. So do you see how LRAM is always an under approximation when the function is increasing? It's going to be the same for this one. So at 0 is what determines that interval for LRAM. For 1 to 2, 1 determines it for LRAM, correct?
Yep.
And then 3 to 2, or 2 to 3, whatever. Yes, just like that. Under approximation once again. Now we're going to do RRAM for these. So with RRAM from 0 to 1, which of these, yes, is going to determine the height? 1 is going to determine the height here. From 1 to 2, what's going to determine the height?
2.
The height of 2. From 2 to 3? 3. So do you see how RRAM is an over approximation when the function is increasing? And then same thing over here. So 1 determines the height, 2 determines the height, and 3 determines the height. So this is how the reasoning behind why LRAM is an under and RRAM is an over for increasing curves. Does everybody understand that concept? Okay. Now with decreasing curves, it's obviously the opposite. So if we have one like this, I keep wanting to draw this for the other one for some reason. Or we have one like this. We're going to do both scenarios, because why not? And I'm going to go 1 through 3 again. Okay, so for the first one, we're doing LRAM. So for the first interval from 0 to 1, who is determining the height here?
0.
0. Try to do it the best you can, of course. Better than mine, hopefully. Okay, and from 1 to 2, what's determining the height? 1, because it's LRAM. And then from 2 to 3, 2 is determining the height. So do you see how LRAM is an over approximation when the function is decreasing? And then same idea for this one. Same scenario, they're over approximations. When we do RRAM from interval 0 to 1, who's determining the height here? The 1. The 2 and the 3. Over here, the 1, the 2, and the 3. So do you see the difference between under and over approximation with these? So you do have to know these. You can either choose to just memorize it, or you can draw a sketch every time. Okay, so if you forget, this is something you will need to know for the quiz. Okay? All right. Were you guys understanding that it was just too simple? Like you get it like 100%? Okay. All right. So this one here says a particle moves along a horizontal line with velocity v of t. The velocity at selected times is given in the table below. So first thing you should check when you're given a table of values is the independent variable equally spaced? Would you say yes or no?
Yes.
Yes. Independent variable is time, and it's going by 4, correct. So when it's independently, when it's equally spaced, we know that we can adapt the data value so we can do more or less. We have more flexibility versus when it's not, we just have to go with what was given to us. So it says here, use the data from the table to approximate the distance traveled over the interval from 0 to 32 seconds from using left rectangular approximation method with 4 subintervals. So 4 subintervals just means 4 rectangles. Yes. So 4 rectangles, which means we need how many data values? 5 data values. So when I do my interval here, I go from 0 to 32. That counts as 2, so I need 3 more. So of course the middle and then the middle of the middles, like that. So those are going to be, that's going to be my number line. So what's the direct middle between 0 and 32? Good. Good. So you see how we're going to be going every 8 values, but the data points give me every 4. So we're condensing that data. We're kind of grouping them together. Okay? So just to be clear with you what's happening here, this grouping right here is associated with this rectangle. This grouping right here is associated with this rectangle because they overlap because they share that data point here to here. And lastly, 24 to 32 is here. Okay? So now we determine what they're asking for. Are they asking left, midpoint, or right? So if they were asking right, what would you put for the yellow one here? That would be middle.
Oh, wait.
9.5 would be right. 8 would be middle, and then this would be left, which is what they are asking for. So basically what this is saying is from 0 to 8, 0 is determining the height of this rectangle because that's the left end point of it. So this is 6.5 height. From 8 to 16, it's left, so 8 is determining 9.5. So you remember if it was midpoint, it would be the middle number, which would be, 10, which would, that's how you do it, yeah. Or 12, yeah. 12 giving 10, yeah.
Oh, yeah.
So for 16 to 24, 16 is determining the height because it's left, so it's going to be 11. And then for the last one, 12. So you're starting to get the idea of the difference between the three. Okay. So now we determine the width. Now what do you notice about the width of all of these because they're equally spaced? They're all 8 apart. So you could either multiply each one by 8 individually and add them up, or you can just do 8 times the sum of all of these. Either way, you get the same answer. And remember that other rule, b minus a divided by n. That would be b minus a divided by 4, which should be 8. Same thing. You're welcome. I know you like that one, so just come full circle with it. And I believe it's 312 from last period. You guys can tell me if I'm wrong. So we multiplied seconds times centimeters per second. So what's left for units? Centimeters, because the seconds cancel out. Okay. So what that basically means is the particle moved a total of. Exactly. So it says assume that v of t is a continuous function. Is the approximation greater or less than the true value? So we have to know two things to figure this out. What method we used, which was LRAM. Okay. And then secondly, we need to look at the y values. As time goes on, are these y values increasing or decreasing? Increasing. I don't know. So LRAM increasing. When we're dealing with a function and we have LRAM increasing, is that an under or an over approximation? Under approximation. You guys get the gist of it, hopefully? Okay. Your table will help you with that. All right. So now we're going to talk about inscribed versus circumscribed. Maybe you remember these terms from geometry. Do you remember the triangles? Inscribed, the median, and remember midpoint and vaguely maybe? There was like a apple butter ice cream, like little, you probably have no clue what I'm talking about right now. Okay, anyways, same idea. So inscribed means that all of the rectangles for the approximation have to fall within the shape. And circumscribed means that each one of these is going to fall outside of the shape in some way, okay? The main thing you should know about this is to know inscribed is inside, circumscribed is outside. Okay, that's like a vocabulary term that would be on a quiz or test. The actual area under the curve must fall between the inscribed and circumscribed area. So what that means is if I have an under approximation and an over approximation, we know the actual value must be between the under and the over at all times. Okay? Everybody understand that concept? Okay. So it says find the area under the curve. So find the area under the curve. Somebody did that last period too. Or no, it was the period before that. Y equals 1 minus x squared between 0 and 1 using 4 circumscribed rectangles. So what you're going to notice here is they don't tell me LRAM, RRAM, any of that. They're telling us circumscribed rectangles. So that's basically telling us we need to make sure that it's an overestimate one way or the other. So we have to figure out which one we're going to use based on what the curve looks like. Which one's going to give us an overestimate for that given situation. So we're going to try to look at the curve and figure out is it increasing or decreasing on this interval. Okay? So here's what we're going to do. We're going to start by setting up our drawing. So we're going between 0 and 1, and we're trying to use 4 circumscribed rectangles. So how many data points do I need? 5 data points. So that means I'm starting at 0. I'm ending at 1. And between that, I know I have to have 3 more data points. So what's the exact middle here? Good. Between 0 and 0.5? Good. And here? Good. You can either go by 0.2s or by 0.25s on this side. So I'm going to go up to 1, and then I'm just going to do the same scale over here. Now, if I hadn't tested this ahead of time, you just want to make sure that the data points that you're going to actually get when you plug them into the function are going to be within this range, which they are. If I plug in, for example, 0, I get 1 minus 0, which is 1. And if I plug in 1, I'm going to get 1 minus 1, which is 0. So all my data points are going to fall between 0 and 1 when I plug them in. Okay? So when I plug in 0 into my function, I get 1 minus 0, which is 1. I'm going to plug in 0.25. And I get 0.94, so somewhere around here. I'm going to put 0.94 because we're going to need it later, what the exact value is there. Next one I'm going to plug in, I'm going to do this one first just because it's easier in the calculator. This one here is 0.44, and then 0.5 is 0.75 right here. And then lastly, if I plug in 1, what's 1 squared?
1.
Yeah, it's going to be 0 because 1 minus 1. So does everybody see how we got each of those points?
Yeah.
Now we're just going to connect them. And now you're looking at your picture, okay? Is this increasing or decreasing? This is decreasing. And we want circumscribed rectangles, so do we want an overestimate or an underestimate? We want it to be overestimated. Thank you. So if we want decreasing and an overestimate, we're going to have to use which one? Left. If you weren't sure, you can look at your chart on the back of your notes. Okay? So everybody see why we have to use LRAM here. Okay. So in order to use LRAM, it's going to be determined by the height of the one on the left, so the height of 0 here, the height of 0.25, the point of 0.5, and the height of 0.75. So we always leave out the last endpoint calculation. So what is the width of each of those rectangles?
0.25.
So 0.25 is my width, or you can also do 1 minus 0 divided by 4, which is 0.25. And then we're going to multiply by the heights of the 4 rectangles. So the height of the first one is 1, plus the height of the second is 0.94. That's why I wrote it, so I didn't have to do the calculation again. 0.5 is at 0.75. And the last one is at 0.44. And whatever you get there will be the answer to your question, so let's do it. And you should get about 78.78. So any questions about that? Yes.
I understand how you got your y values, but how did you know what values you wanted to put on your y-axis? Was that just like an estimation of what you thought you would need?
Oh,
Or did
yeah,
that come from
that's a
actual-
good point. So when I did this ahead of time, I tested each of these.
You
Well,
plugged it in.
I plug it in, and I also, it's hard because I know what that function, I know none of the values. If I'm plugging small values in here, I know that none of them are going to be bigger than the endpoints. They're going to all be between those endpoints. So that's how I thought about it. But like, you don't have to think that vastly. You can just plug them in and test it first.
Okay.
Okay.
Makes sense. Thank you.
You're welcome. All right, so this is your schedule coming up. So a few mentions before you guys start on your homework. Today you have, like, I'll give you the homework to start, but you're gonna have a work day tomorrow, which this is tomorrow. Okay, you're gonna have a work day. But keep in mind the Delta Math you're gonna have the review for is you only have 1 day to do that. So I recommend trying to get your homework done so you have a little bit of time at the end of class on the last few days to start the Delta Math early so that you're not ending up with homework. With this assignment, just like the last one, some of them are a little